Hello, this is Mrs. Grizafi. We are on 9.05 pre-calc. So we're going to be talking about polar coordinates today. So a little bit different than our conics. It's kind of just an add-on to this unit that we're doing. And then soon we'll be moving on to limits after this. So very exciting stuff coming up. And I think that we will be having an assessment on Unit 7 and 9 coming up relatively soon after we finish up Unit 9, and then we'll have a review, and then we will do an assessment test of Unit 7 and 9. All right, so just so you guys kind of know what's coming up at this point. All right, let's get going on these. So we've got some vocab first off. So R in polar coordinates is representing a directed distance. So kind of like when we talked about with our vectors, they have a directed distance. So it's a certain amount of units that you've gone, but it's in a specific direction. And theta is our directed angle. And you always measure that, just like we always have, counterclockwise from the x-axis, but now we're going to be talking about it as the polar axis. But to you guys, you've always known that as the x-axis, because this is a totally different grid. So before, we've always talked about plotting points on the rectangular coordinates on our coordinate grid. These grids are going to look a little bit different. So just so you get an idea here, you've got your pole is going to be right here. That's kind of your vertex for what I'm drawing. And then your x-axis is going to be the polar axis right there. And then this point right here, let's call it P, we would call the coordinates r, theta. And to get to this point, the distance from your pole to point P, that's your r, which is your directed distance. All right, and just for you guys, so you kind of understand where you may need this, it's used by a lot of physicists and engineers. It's used on machines, electricity, magnetism. They use it a lot for when you're talking about generating power, things like that. So it does have quite a few applications as well. All right, so we're talking very basic today, just kind of how to plot points in the polar coordinate system. So to plot a point, you've got two things you're looking at: your directed distance and theta, your angle. So r, theta is how we plot a point. We want to plot the point 2, pi over 3. So when you talk about your distance, you're talking about how many rings you are from the pole. So here's our pole. So if we're going to be at 2, then we're going to be 2 rings out. So we're going to be somewhere on this ring right here, because that's the second ring. Pi over 3 tells us where exactly we're going to be on that ring. So we want to go pi over 3. So I've put this grid on here. This one's going to represent your pi over 6, pi over 4, just like on your unit circle, pi over 3. Here's your pi over 2. So if we want pi over 3, that's going to be right here is pi over 3. So that's our theta that we want. So where they intersect, that is our point P, let's call it 2, pi over 3. So you've gone 2 units out, so 2 rings out, and you've gone from your polar axis, which our polar axis is right here. So that's like our x-axis. We've gone up pi over 3 from that. And that's it. That's how you plot the point. Let's try another one. So this one we're going negative pi over 6. Let's find the angle first this time. so we don't have to draw in this whole circle. So I'm going to go negative pi over 6, which means I need to start by going down first. So this is going to be negative pi over 6, negative pi over 4, negative pi over 3. So I'm going to go somewhere along this line right here, because that's negative pi over 6. And it's positive 3, so I'm going to go 3 rings out. So that's my point 3, negative pi over 6. So this pi over 6, negative pi over 6, if you negate the first number, it just means you go 180 degrees the other direction. So you would be on this side 3 rings out. So it actually changes the angle. So there's a lot of different ways we can write the same point, and we'll talk about that in just a couple minutes. Let's do another one. Actually, good idea to pause the video here and try this one on your own. All right, so you found 11 pi over 6. So we know this is 1 pi over 6, 2 pi over 6, 3 pi over 6, or 1/2 pi. We've got 4 pi over 6, and this 5 pi over 6. So this would be 4 pi over 6, 5 pi over 6. We know this is 6 pi over 6 because that's the same as just pi. We need to get to 11 pi over 6. So we go 7, 8, 9 pi over 6, 10, 11. Or you may have said 12 pi over 6 we know is 2 pi, and go 1 down from that. Gives me 11 pi over 6. So I have to be somewhere along this 11 pi over 6 line. So if I'm in this quadrant 4, and my first number is positive, I'm going to stay in quadrant 4. So I'm going to count 1 ring out, which is right here. So that would be my point 1, 11 pi over 6. And then the last one, we're going to find 5 pi over 6. So first I'm going to say, well, where is 6 pi over 6? I know 6 pi over 6 is over here. So I'm going to go 1 less than that. So that gives me 5 pi over 6 here. But this time, our R value, our directed distance, is negative. So instead of being 2 rings out here, I'm going to actually extend this line. So this line is the angle. Instead of being 2 out and staying in quadrant 2, I'm going to go the opposite direction from the pole, and I'm going to count 2 in the other direction. So it's positive if it stays where that angle is. But if it's negative, you count on that same line, just extend the line, but in the opposite direction. So this one right here would be negative 2, 5 pi over 6. So that's what a negative R value will do. In rectangular coordinates, which was what we're used to using, each point xy has a unique representation. So anytime you give me an ordered pair, I can find exactly 1 point that satisfies that. And that's not true for polar coordinates. We've got multiple points to say the same point that we're trying to get. So r theta, you could also say, is keep the r the same, and then you could take theta and add or subtract 2 pi. Because anytime we add or subtract a full circle, you end up in the same spot. So 2 pi is the same as 360 degrees. So if you add a full circle or subtract a full circle, you'll be at the same exact point. Another way to get to the same point is if you take theta and you add or subtract half of a circle, so pi. So if I add half a circle, then looking at this last one up here, if I add, actually, let's look at letter C. If I added half a circle here, this green point would be over here. But if I want it to be the same point, I would have to negate r to bounce it to the other side. So I would have to do negative r and then add pi or subtract pi to it. So if you add a half of circle or 180 degrees, then you need to just negate r and you'll still be in the same exact spot as you started. Okay, so number 2 says plot the point and then find 4 additional polar representations of this point. All right, so let's start by plotting it. First, we're going to go to negative 3 pi over 4. So if it's negative, we're going to go down. So this is negative 1 pi over 4. And then here's negative 2 pi over 4, or negative pi over 2. Then we have negative 3 pi over 4. So somewhere along this line, it's a positive r, so I'm going to stay in this quadrant where the angle lands. And I'm going to go 3 rings out. So 1, 2, 3 rings. So that's the point 3, negative 3 pi over 4. If it had been negative 3, then I would be on this side over here. Find 4 additional polar representations. So 1, I'm going to take this green point and I'm just going to add 2 pi to theta. So I'm going to keep my r the same as 3, and I'm going to take negative 3 pi over 4 plus 2 pi. So you can do negative 3 pi over 4 plus 2 pi in your calculator, or you could multiply this by 2 over 2 to get 4 pi over 2 without a calculator. And negative 3 plus 4 is 1 pi. Oh wait, we want to get a denominator of 4 actually. Scratch that. You want to multiply it by 4 over 4. So that would be 8 pi over 4. There we go. And then we have negative 3 pi plus 8 pi would give us 5 pi over 4. So our new point would be 3 and then 5 pi over 4. So let's double check that would work. So find 5 pi over 4. So here's 1 pi over 4, 2 pi over 4. Oh, no, sorry. 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Well, that's good news. And then we'd go out 3 rings. So that's exactly the same. So if I gave you this point, you'd get to the same exact point as if I gave you that one. Number 2, let's subtract 2 pi from theta. Subtract 2 pi from theta. So we keep r the same, and this time we'll take negative 3 pi over 4 minus 2 pi. So again, you could do that negative 3/4 minus 2 in your calculator, or negative 3 minus 8, which, because we said 8 pi over 4 is the same as 2 pi. And that leaves me with 3 and negative 11 pi over 4. So if I wanted to graph this to make sure, I would go down 11 pi over 4. So negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 would bring me back here again, and 3 rings out. Number 3, replace r with negative r. So negate r and add pi to theta. So instead of 3, we're going to make it negative 3, and we're going to take negative 3 pi over 4 and add pi to that. So that would be the same as adding 4 pi over 4 to that. So that will give me negative 3, and then negative 3 plus 4 is 1 pi over 4. So if I went up, I'm going to erase some of these lines I have drawn in here. If I went up 1 pi over 4, that brings me to here. But if I want to graph negative 3 as my directed distance, I'm going to extend my black line out, and instead of counting 3 lines up, I'm going to go from the pole and I'm going to go in the opposite direction. Still along that line, 3 circles out. So 1, 2, 3, and that again brings me to that same point. And then lastly, we're again going to replace r with negative r, so negate r, but this time we're going to subtract pi from theta. So negative 3, and we'll do negative 3 pi over 4 minus pi, which is negative 4 pi over 4. and we get -3 and -7 pi over 4. So these are 4 different ways of representing the exact same point. So they all will get you to this point right here. Okay, for number 3, it says plot the point, find 3 additional polar representations of this point using -2 pi is less than theta, which is less than 2 pi. So just a little bit different in the end. We're going to have to reject one of our answers because we want to make sure they're all between -2 pi and 2 pi. So feel free to pause right here and try this one on your own. I'm going to go through it as well, though. First, I'm going to plot it. So I'm going to find -pi over 3. So this is -pi over 6, -pi over 4. Here's -pi over 3 along this line right here. So if I wanted to graph 1, -pi over 3, I would go 1 circle out. But this says -1. So now I'm going to take -pi over 3 and extend it. So it goes up to the opposite quadrant. And then in the quadrant that's opposite 4, I'm going to count 1 circle out, 1 ring out. So this is going to be my point, -1, -pi over 3. So if it's negative, you should be going to the opposite quadrant. All right, so if I want other representations, I can keep the -1 and then take my angle and add a full circle to it. Because if I add a full circle to that, I'll end up in the same spot. So if we do that, again, you can put that in your calculator or get a common denominator. Here you'd have to do 6 pi over 3. 6 minus 1 is 5. So there's one answer. Is theta between -2 pi and 2 pi? Yeah, it would be over 2 pi if we had a number greater than 6. 6 pi over 3 would be 2 pi. So any number bigger than that would give us over 2 pi. Okay, for the next one, keep -1, take our angle. This time, let's subtract 2 pi from this angle. So instead of adding 2 pi to it, we're going to subtract. So this would give us -1. This is -6 pi over 3. So -6 minus 1 is -7 pi over 3. Now here, we end up with an angle where a number is bigger than 6, and it's -7 pi over 3. So that's going to be less than -2 pi. So we can't keep this because it is not within our interval. So reject because it's not in the interval between -2 pi and 2 pi. All right, now let's do the next one. So the next one, we're going to negate the -1. So that one will become +1 and take our angle and just add half a circle to it. So add 180 degrees. Why does this work? Well, when you negate the r, you're going 180 degrees. You're going to the opposite quadrant. So if I add pi, so add 180 degrees to my angle, and then also negate, they're doing the same thing. When you add 180 degrees is the same thing as negating your r. So if you do both of those things, you're really in the same spot that you started. So this would be +1, and then this is like 3 pi over 3, so 3 minus 1 is 2 pi over 3. And that one is less than 2 pi, so we're good there. And then the last one, take our -pi over 3, negate the r again, and this time you're going to subtract your 3 pi over 3. So we get 1, -4 pi over 3. Again, 4/3 is less than 2, so we can keep this one as well. So those are our 3 different representations. Now let's talk about converting between rectangular coordinates and polar coordinates. So let's let the polar axis coincide with the positive x-axis and the pole with the origin. So here's your pole and your origin. This is your x-axis and also your polar axis. So to derive our conversions, think about if it's rectangular, if we go over, that's x, and we go up, that's y. If we think about our polar coordinates, from our pole to our point, represents your directed distance, which is r, and the angle is theta. So we have both our rectangular coordinates. So first we'll go from rectangular, which is xy, to polar, which is r theta. So those are kind of the letters that we're focused on getting here. So if we want to get from rectangular, so if we're given x and y, how can we get an r from x and y? Well, this is a right triangle right here. So we could do Pythagorean theorem. So x squared plus y squared equals r squared. So that'll give us r if we know x and y. So now if we know x and y, how can we get theta? Well, what's the relationship using this picture? Well, we have x and y. If we already know those, we have the opposite and adjacent side. So we can use tangent. So tangent of theta equals opposite, which is y, over adjacent, which is x. And those are the formulas that you'll need to know. If you're going from rectangular coordinates to polar coordinates, let's do the other direction. So let's say you're given the polar coordinates, so you know r and you know theta, and you want to get to the rectangular coordinates, which is x and y. So if I already know r and theta, how can I figure out x and y? Well, what if we know theta and we know r, and we're trying to find x, let's say, what's the relationship between those three, or what relationship can we form? Well, we know that cosine of theta is equal to adjacent over hypotenuse. So x over hypotenuse. And then you could cross multiply here if we want to solve for x. I could cross multiply and get r cosine theta equals x times 1. And there's our first formula. So x equals r cosine of theta. And then you could do the same thing for y, except when we do y, that's our opposite side and our hypotenuse. So we would use sine. So sine theta equals opposite, which is y, over hypotenuse. Cross multiply, we get r sine theta equals y, or y equals r sine theta. So these are the formulas that you guys have to have memorized in order to convert from rectangular to polar, or from polar to rectangular. So really make it clear in your mind which one where are you going from? Am I going from rectangular to polar? In that case, use this side. If you're going from polar to rectangular, use the other side. Let's do a couple practice. Number 4a, convert the following from polar to rectangular. So go back up and look, okay, if I'm going from polar to rectangular, that means I know r and theta, and I want to get to x and y. So what formulas am I going to use? Well, I'm going to use that x equals cosine, r cosine theta, and I'm going to use y equals r sine theta, because I know r and I know theta, and I'm trying to find x and y. So now once you've got the formulas, that's the hard part. You're just really going to substitute in. So x equals, so this is your r and this is your theta, so 2 cosine pi. If you need to draw out your unit circle, here's pi over here. Coordinates are -1, 0. Cosine always comes first and then sine. So the cosine of pi is -1. So that's 2 times -1, which is -2. Y is 2 sine of pi. So sine's the second coordinate, which is 0. So 2 times 0, which is 0. So -2, 0, that would be your rectangular coordinate. So what that means, if you were to graph this out, so if we said, okay, we want to graph the point pi, that's over here, and then 2, we're going to go out 2 circles at this point right here. If I want the rectangular coordinates of that, I'm going left 2 unit, 2 boxes, and up 0 boxes. Ends up in the exact same spot. So it's the same location that you're graphing in rectangular as it is in polar. All right, let's try letter B. And again, good idea here, pause the video, see if you can do it on your own. Okay, so we've got r and theta. We're using those same formulas. So I'm going to say x equals my r, which is rad 3 times cosine of pi over 6. Again, it might be helpful to draw out your unit circle. You need to have the cosine of pi over 6 memorized. So you might draw your 3 angles here. So pi over 6 is your first one, and that's going to be rad 3 over 2 comma 1 half. Remember, it's 3, 2, 1, 1, 2, 3. So the cosine of pi over 6 is rad 3 over 2. Put that over 1, so they're both fractions. Rad 3 times rad 3 is 3. 2 times 1 is 2. And then do y. So y is rad 3 times the sine of pi over 6. That's rad 3 times 1 half. Put rad 3 over 1. Multiply straight across the top, straight across the bottom. So in rectangular coordinates, my x is 3 over 2, so 1.5. And my y would be rad 3 over 2. So you would go up that decimal. And that's it for converting from polar to rectangular. Now let's go the other direction. So if I give you rectangular, I give you the x and the y, I want you to be able to come up with the polar coordinates, so r and theta. So the formula is, if you know x and y already, you're going to use your Pythagorean theorem to find r, and then use the fact that tan theta is equal to opposite over adjacent, or y over x in this case, to find theta. So this is your x and this is your y. So first let's do -1 squared plus 1 squared equals r squared. So 1 plus 1 is 2. Take the square root, and r equals the square root of 2. I know that it is the plus or minus square root of 2, but you only need to give me the positive one here, because we're going to find the angle that it makes. So we're only going to go with a positive number of circles that it makes. So now let's do our tan theta equals y over x. So tan theta, our y is 1, x is -1. So the inverse tan of -1. So again, this one you should be able to do without a calculator. You're trying to think about which angle, when you do sine over cosine, would give you a 1. So remember, this is rad 3 over 2, 1 half, rad 2 over 2, rad 2 over 2, and then 1 half, comma, rad 3 over 2. 3, 2, 1, 1, 2, 3, all over 2. So which of these, when you do tan, so tan, remember, is sine over cosine. If you take the second coordinate and divide it by the first one, which of them would give you a 1? And it would be this one. So that's our reference angle, is pi over 4. Now clearly it gives us a positive 1, not a -1, so it's not the first quadrant. We need to figure out which quadrant it's going to be in. So to figure out what quadrant, plot this point. -1, 1 is in quadrant 2. So instead of finding what 2 quadrants is it possible and then rejecting one, just figure out what quadrant you are going to be in. You're going to be in quadrant 2. So put pi over 4 in quadrant 2 as your reference angle. We know this is 4 pi over 4, so this must be 3 pi over 4. So in quadrant 2, we're 3 pi over 4. So your final answer would be r, which is rad 2, comma 3 pi over 4. And those are both exact values. All right. And the next one says find 2 sets of points for this one. So first, let's find the one, and then let's find a second. So it's kind of combining the 2 things that we've done here. So conversions, and then also finding multiple representations. First thing you might want to do is think about what quadrant that's going to be in. So if you were to graph rad 3, that's going to go to the right, so it'd be positive. And then down 1, oh, everything came back, is going to be in quadrant, and there it goes again. So we're going to be in quadrant 4. So let's use our formula. So we've got our Pythagorean theorem. So we're going to take rad 3 squared plus negative 1 squared equals r squared. That's 3 plus 1. Excuse me. 4 equals r squared. So r is going to be 2. So we're going to go 2 circles out. And now we need to find theta. So tan theta equals y over x. So my y is negative 1 over rad 3. Again, let's look here which one is, so we're going to try and do this without a calculator. Sine is negative 1 and cosine is rad 3. So that looks like it's going to give us this one right here. And that means our reference angle would be pi over 6, but we already said we want to be in quadrant 4 based off of where that graphs in the rectangular axes. So in quadrant 4, over here, if that's our reference angle is pi over 6, we know this is 12 pi over 6, which is 2 pi. So 1/6 less than that would be 11 pi over 6. So our answer would be 2, 11 pi over 6. Now it asks for 2 sets of points. So we have those 4 different options of finding another point. But before you go through all 4, try just thinking through it using a picture, a graph, using the graph to see which will give you theta between 0 and 2 pi, which is what they asked for here. So think about if you are on your set of axes and you've graphed, let me draw my 2 circles. I'm at 11 pi over 6. So that's going to be down here, we said, in quadrant 4, 2 circles out. If I add a full circle to that, if I add 2 pi, and I'm already at 11 pi over 6, and I add another 2 pi, am I going to be bigger than 2 pi? Well, yeah, because I'm adding 11 pi over 6 to 2 pi. Yes, that's going to be bigger than 2 pi. So that one's not going to work. What if I subtracted 2 pi? So if I have 11 pi over 6 and I subtract 2 pi, will I be less than 0? Yes, you will definitely be less than 0 then. What if I add half a circle rather, so I add 180 degrees and I go over here, would I be bigger than 2 pi? Well, if I'm at 11 pi over 6 and I add 1 pi to that, yes, I will, because that's like adding 6 pi over 6. Okay, so what if I subtract 180 degrees? So I subtract pi from 11 pi over 6. Will I be over 2 pi? No. Will I be under 0? Not if I'm just subtracting 1 pi. So let's try that one. So I'll take 11 pi over 6 minus pi, which is 6 pi over 6. And if I subtract just half a circle, that means I need to negate my r. So I'm going to make it negative 2. So that would be negative 2 and then 5 pi over 6. So theta is between 0 and 2 pi. And then we negated r. It didn't have any restrictions on that. Now, that is a lot to think about. So if this was too much for you just to process, write out all 4 representations, find them all, and then see which one has theta between 0 and 2 pi. And then just seeing them might make it a little easier for you to pick it out. Okay? And that is it for our intro to polar coordinates. Hope you're all staying healthy, staying strong, loving math, doing lots of math dances, and pie out.